Hello and welcome to my channel. So today let's look at the daily challenging question. The Leetcode 368, largest divisible subset. Given a subset of distinct positive integers norms, return the largest subset answer such that every pair, answer I, answer j of elements in this subset satisfy the answer I mod answer j is 0 or answer j mod answer I is 0. If there are multiple solutions, return any of them. So the input norms 1, 2, 3, then the output can be either 1, 2 or 1, 3. So in the 1, 2, that each element is divisible by 2. So like also in the 1 tree it's the same, like 1 is divisible by 3, but 2 is not divisible by 3. So so 2 cannot be put into the 1 tree output. And similarly 1 2 example 2 1 2 4 8. So 1 2 4 8 is each element 1 2 4 are all like a factor of 8. So they are actually in the same divisible subset. So the answer, the question is asking you to return the largest divisible subset. So the norms length is between 1 and 1000. So this has like an indication that the n squared solution will still work. And so norms I is this means norms I will be integer, like in the integer range, positive integer, like between 1 and 2 times 10 to the power of 9. And all the integers in norms are unique, so there is no duplicate. Yeah, so this question we can use the dynamic programming DP approach. And so the step 1 is sort norms. Step 2, actually we need, for the DP we need to have a transit function, right? So we need to derive this derive this DP array. So the DP array we can call it DPI, and I is DPI, the largest divisible subset, ends with norms I, and also it need to include norms I. Then we can derive the equation. So the DPI is dpj plus 1. So DPI will be the max dpj plus 1 for j smaller than I, and norms I mod norms j is 0. So this is the transit function. So we need to traverse all the, enumerate all the j's smaller than I, and check if norms j is a factor of norms I, then we can update the norms DPI. And also the initial condition. This is the transition function, and the initial condition is all the dpi is 1, because the smallest the divisible subset ending with norms I actually is minimum is 1. And so this is like how we get the max the size of the largest divisible subset. So there is still a little trick that we need to use to print out the largest divisible subset. But yeah, I will show you what in the implementation. But the time complexity here is it will be n squared, because there is a double loop. For I is from 0 to n minus 1, and j is from 0 to I minus 1. So it will be n squared, and the time, this is the time. So and the space is it will be on, because the dp array will have only like n elements. Yeah, so now let's start implementing this. Firstly, I will get in the code for the getting the max size of divisible subset. Then I will show you how to print it out. So firstly, sorting the norms. Then define this dp. Yeah, getting n from the norms length, and dp. So then we can use arrays dot fill dp1 to initialize all the dp element as 1. Then next we can start iterating from I to I minus 1, and then inside loop is from j to j until I minus 1. So here, if norms I mod norms j is not 0, then which means it's not satisfying the condition, so we just continue. Otherwise, we can start updating. So dpi will be math.max dpi, so dpj plus 1. So after this all done, then the dp, but actually we don't know that the maximum divisible subset is ending with which index, with which element. So we need to check all the end element. So we actually can have a max length dpi. So yeah, so this is the to getting the size of the largest divisible subset. But how do we print it? To print it, we can use a helper array called Prius, which is the same size as dp. So the Prius using get n. Then the Prius we will fill it with minus 1. So so what the Prius does is it will record the path to get into the max length. To get into the largest divisible subset. So so here, if we have updated the dpi, we just do a check. So if it's updated, then the previous actually will point to j. Previous I will be j. So the and mm, yeah, and also here, if the max length is equal to dpi, then we need to record the index. So we can use another called max index. So which means the max index is um, at I. So after this loop is done, the max index will point in the last element of last index of the largest divisible subset. And then now we can we need to print it out, right? So we need to have an answer list. We can define an ID called to assign the index max index value. So while ID is not -1, then we can go from ID to the previous one, previous index, and then we can append the nums ID to the answers, and because this one in this loop we are appending the largest element firstly, smallest elements lastly. So we need to reverse this answer, so that it will be in the order of small to large, and then we return the answers. So so let's check if this is a code has anything wrong with using the OJ. Okay, yeah, so it looks correct for these two test cases. Okay, cool. Yeah, so the question, this question is we use dynamic programming and using 1D dynamic programming array, and so the dynamic TPI will be actually the size of the largest the size of the largest divisible subset and with on num size. So we have a double loop I reiterate I to n minus 1 and j from 0 to I minus 1. Then we check if the nums I is if nums j is a factor of nums I. If it is a factor, then we can update the DPI. So in the end, but still we don't know like which index is the largest the last element of the largest divisible subset. So we need to check all the index. So here we did that max length. Then also we have we used the previous index previous integer array to to record the path we get from J to I. So this previous index array will help us to print out the all the elements in the largest divisible subarray. So this conclude the time complexity is n squared, and so this conclude today's session. So if you have any question, please comment on the video, and thank you.